anomalies and some particular CADASIL mutations. It has been reported. Some mutations that are associated with it. Very small studies though.
And like kidney problems?
It has been reported to very small studies, but it's out there. So here I'm showing you actually the arteriopathy. This artery is too thick, and there are some deposits here that then if you look at them by electron microscopy, you see them as gone. And this is actually, you know, a lot of people, they wanna also, they help with, you know, research when they are alive, and then they donate the brain, and we can do research in the post-mortem in the brain, and you can see here the lesions at the microscopic level. Okay? Now, we're going deeper. What is this? What does this represent?
Fire escape.
Okay, that's a wild guess. What else?
Is that where you find your
Notch 3? Notch 3, okay. Someone mentioned Notch 3. Does this look, why do you say Notch 3?
If there's 19 of those, are there 19, or at least 19 of those white boxes?
Okay, there are some white boxes here, and there are many of those.
Yeah.
And then there is here, like, what is this?
It's
What does this represent?
the 19th one.
Magnify, and then we see this. What is this?
That's the mutation.
That's something related to mutations. What else? What was it?
TIAs.
TIAs, this is maybe related with TIAs.
Do the C stand for cysteine?
The C is,
Resisting.
come over here. The molecular biologist in the room. Barbara is going to tell us about it. So you think this C is very conspicuous. It has something to do with cysteines. Okay, how many of them are there?
Of the C, 1, 2, 3, 4, 5, 6.
Okay, and they go where? In each of the boxes.
And those and
Yeah,
these.
okay. So is 6 an odd or an even number?
Even.
Even. Is that important? That's amazing. Thank you, Barbara. You did a great job. So indeed, the molecular biologists in the room identified this as a representation of Notch 3. Okay? This is, Notch 3 is a receptor, okay, in the cells. And a cell, let me go to this. This is a cell. We are all made up of cells. We have millions of them. Just they are tiny, and we just pile them up, and you get a person. Not really. But from a very, you know, minimalistic point of view, we can look at it like that. And the cells are very small, but we can magnify them. And Notch 3 is a receptor that is in the surface of the cell. And because the cell has an interior and it has an exterior, we call this the interior domain, and we call this the exterior domain. This is Notch 3. So in the exterior, that we also call extracellular, exterior domain, this is where all the CADASIL mutations have been located. All of them happen to be there, okay? And they don't affect the interior domain. This is fine. Okay? When you call receptors, what do you think of? What is a receptor?
It receives something.
It receives a signal. Okay? So for instance, the satellites. Where are the satellites? If you're really smart and you want a satellite, where will you put it? You put it like here in the room. Where do you put it? The exterior. That's where they all are for some reason. And when they are here and they crash land and they are useless. Is that correct? So that's why it's handy to have the receptors there at the surface. And this is actually the region that is represented here. There are many different domains. Who cares what they are called? But the bottom line is that each of these domains, well, I'm going to tell you what they are, is the EGF, the epidermal growth factor light repeats. Each of them has 6 cysteines. And when you probably got your DNA testing, I'm sure all of you got this information saying something goes to C, or C goes to something. And this could be another letter. That happened to all of you?
Yes.
The letter, who cares what it is, because it doesn't matter. But this one matters, because it goes to C, or the C goes to something else. So it turns out that these systems, which Barbara correctly identified, they like to be in pairs. That's what they like. And this is why the number is always going to be even. Okay, they like to be in pairs because they like to hang together. It's like, you know, young teenagers, they like to go in pairs. It's just like that. They can't really stand it. They're by themselves. So they like to go in pairs, and when they are not, which could happen when you lose one, or you have an extra one, these are the most characteristic mutations in CADASIL. Okay? Is that clear to everybody? Good.
So, I have one question on it. So, for a person who does not have CADASIL, they still have the notch 3 interior, exterior, but they don't have a mutation on it.
Yes, so if you count them,
They're always even in itself.
they are even.
Okay.
And then when they are odd, maybe they have an extra one or they are missing one, that is diagnostic of CADASIL.
Okay.
That feature. There are other people that have these mutations in notch 3 and they don't involve cysteines, and I've done a lot of research on it. And we still don't understand how or why they still have CADASIL, but most of them, 95% of people, you get 100 people in a line and they all have CADASIL, 95 of them will have this type of mutation. They're very, what we say, stereotype, yeah?
Related to this, what you were saying about all the data test, is that those numbers that they put on the test, are they basically the same on everybody's?
Oh, okay, so the number in between is really, so it's C to something, and this is a letter, or it's something that is a letter to C, and then in between here there is a number that actually goes from 1 up until, could go to, I think, 12, maybe 12, I think at least 1100. This number indicates the position, because we count the, the whole notch 3 is made of amino acids, and each of them we call them 1, 2, 3, 4, 5, and then if here it should be a C, and it goes to something we can call C2R, and it simply says that the cysteine at position 2 went to R. Does that make sense? That's what the number means. The number indicates the position.
And then the
in the gene. Is that what you were asking?
then there's that codon number,
Yeah.
and that is the same in families. My sister and I have the identical codon.
Well, that's what was my question. My father's report came back and everything was identical to mine.
Exactly. It is identical because you inherited from him. So the number doesn't really have anything to do specifically with you. It's basically the mutation you inherited from your dad.
So that is the specific mutation.
Yes,
And
that is.
somebody else in this room probably has a different number.
Right.
It has a different number, and it could be R it could be actually, I'm going to speak about some mutations. Cysteine 455 to R. I'm going to talk about another one that is R1031 to C.
So that's where you're talking about the different families. The
Different families can have different mutations, and the disease can manifest itself differently in these patients.
And so can you identify, at least among those numbers that you have, the severities of the disease?
Oh yeah, I'm going to tell you something amazing about it. And it's something, it's part of some of the discoveries that I greatly contributed to. It's one of my contributions to the field. I'm going to tell you about that, okay? Because there are some mutations that are more aggressive than others, and they are associated with early onset. And they tell us a lot about the disease, and this is why now we have hints to the cure. The hint to the cure for the disease, what I think could lead us to a treatment, comes from one of these Colombian patients that lived in one of these villages. And I'm going to tell you a fascinating story of how we took this all the way, okay? And it has to do with that. Something we learn from the patients, something that we learn from a meeting like this, is teaching us at Harvard and at other universities how we can cure CADASIL. So this is why I meant it when I said it that the patients know about it the most. So CADASIL unresolved issues, we need to learn more about the mechanism. We have to characterize the GOMs. We need to see how this affects the cells. This is smooth muscle. We haven't really talked about too much about it, but these are the cells that express NOTCH3. These are the smooth muscle cells. You have hoses. Each hose is made of a different material. Okay? Some of them are plastic, some of others are metallic. You can make it out of rubber. It happens that the arteries, which look like hoses, are made up mostly of smooth muscle cells. That is what they are made of. These cells that are smooth muscle. And they happen to express NOTCH3. If you look at other cells in the body, they don't have NOTCH3 and they are fine. But the ones that do happen to be in the vessels and they happen to express NOTCH3. Okay? So, by learning about these unresolved issues, by learning how the mutations are related to the pathology, how they lead to GOMs, how they affect the smooth muscles, we can learn about how this relates to the different presentations of the disease, how they lead to stroke, and hopefully we can develop therapies. And this is something that I've been doing in my research for a long time. So this is the first part of my presentation, and we are actually on time. So what I invite you to do is the following. We have half an hour, which is a long time. So we need half an hour for a coffee break. This is what I want you to do, and I invite you to do the following. I have some questions here for you, and I want you to work on them. I have like enough sheets. Please, write your answers and enjoy coffee. It's okay to cheat. I'm not gonna be like, I do that with my undergrad students, but you're okay. It's okay to cheat. You can talk about your answers with others and just write them down, and in half an hour we'll reconvene. And well, I don't even know what's your plan for the coffee break. I'm not running the show. But
we're going to eat.
Oh, excellent. And in between they can work on this.
Yeah.
Excellent. So I'm just going to pass them on, and this is what is going to lead us to the next session, where we are going to talk about my research, and we're going to talk about
I thought about doing that.
Well, she kept going like this. I was trying to figure out
how to design therapies.
I thought maybe she was at Arsenio Hall's concert or something. I'm sure.
¿Qué tal? ¿Todos son de Puerto Rico?
Yeah.
¿Y se hablan español y ya se les olvidó?